Jai Hind everyone. So today we have picked topic is strengthening from material science. So here we are going to discuss how we can improve the material property by imparting various mechanism of this strengthening. As you know, during plastic deformation, lot of dislocation will happen in material. So because of this location, what is going to happen? You are going to lose some material property, means whatever is strength, whatever like hardness you are desired, that may you are not going to get. So to overcome this, we have to opt various strengthening mechanism. Through that, we can impart some strengthening things in material so that it can avoid dislocation, slipping, twinning, all these plastic dislocations. So as you know, during plastic deformation, the material when unloaded from the load, it is not going to come in their original position. For that, because of that, like some displacement in atoms will happen, and that is going to lead this kind of dislocations and defect in material. So strengthening basically is going to provide, or it is going to improve material property. And if we go through the basic definition of strengthening, here you can say ability of material to deform plastically depend upon the ability of dislocations to move. If material is not easy to dislocate, so it means that having good strengthening property. So here you can see also hardness and strength are related to how easily metal plastically deforms. So by reducing dislocation moment, the mechanical strength of any material can be improved. So this we have to take care. During like stress strain diagram of like suppose this is stress and this is strain. During stress strain diagram of mild steel, we have gone through. During this region, we can also strengthen material by strain hardening. How? We can just pull the load and again release the load. Again pulling the load and releasing the load cyclically, it will improve the strength of material during this region. As we know, this is plastic regions of any material. If material enters in this zone, it cannot be like get into their original shape. So hardness and strength is very important property. If we have to take care of that, so we have to avoid this strengthening mechanism. So to if we want to like improve any material based on the like mechanical property, so there are certain ways through that we can do this task. Like strengthening mechanism is the relation that defines how dislocation, motion and mechanical behavior can be correlated. So it is going to create some relation in between dislocation, motion of the like atoms as well as mechanical behavior of material. So if we are going to control on this, so easily we can improve mechanical behavior of any metal. So again we can say the ability of metal to plastically deform depends upon the ability of dislocations to move. If any material is easy to dislocate, that means we are going to get very quickly this plastic deformation. If material is not ready to change their property, then it is very tough to enter in plastic zone of or plastic region of that material. So plastic deformation depends upon the ability of how your metal is going to sustain against these dislocations. So there are certain methods available. By using that you can improve the like strength of any material. Like if we have control on grain size reduction, then solid solution alloying is one method. Strain hardening or cold working is one method. Then last is through annealing. It's a process that comes under heat treatment process. Through that also you can improve the strength of any material. One by one we are going to discuss all these four terms, how we can increase strength by using each one of that. So let's take up the first mechanism, that is grain size reduction. So grain size reduction means if you are going to create a mechanism through that you are reducing the grain size, it means there is no space for slipping, for any kind of dislocations. Means you are going to tightly pack that particular zone material, so there will a very minimum chances that any kind of dislocation will happen, and grain boundaries are the barrier to slip. So here if you see, if two grains are there, like grain 1, grain 2, grain 3, so here this is the boundary for any grains. In between that grains, I think if you go through any microstructure of any material, so you will see so many divided parts are there. So this is one zone, second zone, third zone, and this particular thing is known as grain boundary. So grain boundaries are the barriers for slip. If these grain boundaries are going to act as a barriers, means you are going to get maximum strength in your workpiece. So like here, barrier strength increases with this misorientation. So we have to avoid this misorientation so that we can get good strength in material. A smaller grain size, more barrier to slip. So this is again we have to take care. So through that, this is two grains, grain 1 and grain 2, that is separated through one grain boundary. And if we can avoid by controlling the grain size, then what we are going to get? We are going to reduce this slip plane. Because of that, material is not able to dislocate. So this is one type of mechanism that you can apply on your material. Then second one is solid solution alloying. As you see here, we are trying to add some solid solution. Here impurities, atoms distort the lattice and generate stress. Stress can produce a barrier to dislocation motion. So small and large substitutional impurities examples given here. So here is small and here is the large substitution. So if you see the size of this is very small. So what we are trying to do, we are trying to introduce some substitute. Through that we are trying to reduce this slip action. So here you can see some stresses are there. Some forces we are applying. So impurity generates local shear at A and B. That poses dislocation motion to the right. So here we are moving towards the right. And if we go through the large substitutional dislocation, here impurity generates local shear, that is again C and D, and it opposes motion to the right. So what we are trying to do here, we are basically trying to substitute some solid solution or some alloy we are going to add in our material so that the space can be reduced, and because of that this slip action can be managed. Coming to the third point or third mechanism, it is known as strain hardening or cold working. It is the simplest method that you can apply on any metal so that your this strengthening mechanism can be improved. So strain hardening is a process to promote the metal harder and stronger due to the plastic deformation. The dislocations are basically generated when plastic deformations occurs in the metal. So this is the basic definition of like strain hardening. As I already discussed in this region, if you are able to see this curve from this, so here what we are trying to do, see, if I am going to like show you, this is our stress strain diagram. So here we are doing up to here, it is elastic limit, then upper yield point, lower yield point, then this plastic region starts. But what we did after this, whenever before this ultimate tensile strength, so this is our ultimate tensile strength point. Before that somewhere here, what we are doing, we are trying to recycle the same. This is the third method, through that we can do strain, this strengthening by strain hardening. That is a cold working process. If you observe this curve, this is same stress strain diagram, but if you observe, this curve started here and close here. So this is our starting point, and again here it is close. So we are doing this thing, we are doing elastic, we are crossing elastic region, then achieving upper and lower yield point. After that we are moving towards ultimate tensile strength. But before that, much before that, what we are trying, we have removed the load. Because of that, this curve dropped here. Now again we are trying to apply load, and now we are going up to ultimate tensile strength and up to fracture. So if this cycle, suppose this is cycle 1 and this is cycle 2. For any material, suppose this practice we are doing again and again. Like this is our job, in that we are applying some forces, tensile forces. We have now, suppose we have crossed the elastic limit. After that we just entered in plastic region and suddenly we remove the load. Then it will come down. Again I am just pulling this workpiece in opposite direction. And now this time it is going up to ultimate tensile strength, up to this. So up to this ultimate tensile strength. So here you can analyze. If you analyze this, let me again clear all things. If you analyze this, the original curve having this much slope. So here we are getting S1 ultimate tensile strength. But because of this behavior, this of cyclic behavior, because of this cycle 1 and cycle 2, now what we have achieved? We have achieved this S2. This is S2. So you can see, for same material, the stress level increased from S1 to S2. So here material is able to sustain more stress, more load. So this is the best part, and this is the simplest thing that you can do to avoid like any dislocation in your material by just doing this strain hardening. Now the fourth method is related to annealing. Annealing is nothing but a heat treatment process. It's a heat treatment process. So annealing is a heat treatment process. Like there are so many other types of process like quenching, annealing, normalizing. But the advantage of annealing is it reduces hardness. If we are going to perform this annealing on any material, it is going to reduce hardness, remove residual stresses. Whatever residual stresses are there, by default that can be reduced. It is going to improve toughness, restore ductility, and alter various mechanical, electrical or magnetic property of material through refinement of grain. If you are remembering this refinement of grain, same thing we are trying to achieve in first method, that is grain size reduction. If we are going to reduce grain size, means very less space for metal atoms to play. means there is very less chance for any dislocation. So in this method also, but by introducing heat only, we are trying to refine our grain so that dislocations and other defects can be reduced. So what is annealing basically? It is various steps involved, like cooling rate is very slow, around 10 degrees centigrade per hour. Process is carried out in controlled atmosphere. Normally annealing is performed in air. Like whatever piece you are going to heat in furnace, we are going to cool it in air, but in controlled environment so that cooling can be controlled. Inert gases to avoid oxidation. During heat treatments, we have to introduce this inert gases, maybe argon, CO2, helium, for avoiding oxidation. Now, used to achieve ductility in work hardened steels. So, it is going to refine your ductility, means ultimately you are going to achieve good strength from your metal piece. So, here if you see temperature versus time curve, so if we are doing full annealing, here we have cross this up to this and then this. Then partial annealing means we are not going up to this full point. Somewhere this is A1 is recrystallization temperature, above that we have to heat, then cool in controlled environment. Then subcritical annealing. So these three types of annealing is available. You can choose any one as per your requirement and go with this temperature zone, whether we have to heat it above recrystallization temperature or below or in between that you have to check with the standard data sheet of any material, and you can process this thing in furnace, then cool that particular part in air in controlled environment so that we can achieve material with refined grain, so that dislocation slips can be avoided and our strength of our material can increase. So this is all about strengthening mechanism. Through that you can avoid any kind of defect in material, any kind of slip, any kind of training, and also it is going to increase material strength, as you see in this stress strain diagram of strain hardening. We have shifted ultimate tensile limit from this level to this level because of this mechanism only. So this is the best way of improving your material property. So thank you all for listening me. Thank you and Jai Hind.